So let's get cracking on ratio in terms of a letter. So like with Pythagoras type questions, ratio in terms of a letter is a question that you were first exposed to when you were in grade 11. And it's something that often comes up in exams and test questions, that kind of thing. And that's why it's important that we have a look at these types of questions and what it is that they're expecting us to do when we have to apply compound angle formulae and double angle formulae to the mix as well. All right, so I'm going to do one as an example with you, and then I'm going to give you guys an opportunity to practice something like this as well, and then we'll mark it and we'll move on to something else. All right, so just a reminder about our compound angle formulae. That's at the top of the screen. So cos A minus B, cos A plus B, sine A minus B, and sine A plus B. Just have a quick look over those. And then our double angle formulae are there as well, sine 2A and cos 2A. We're going to be using all of those when we now answer these sorts of questions. All right, so the first thing comes up and it says, if the cos of 25 is equal to k, determine the following in terms of k. So these sorts of questions are related to the questions on Pythagoras. And even though it doesn't say so, we can still draw a diagram. The difference between these sorts of questions and the Pythagoras questions is that here you are always going to be working in the first quadrant because the angle that they give you over here is always going to be acute. So I'm going to draw myself a diagram. I'm going to draw my terminal arm. This angle over here is the one that is 25 degrees. And what we would do here is we would interpret K as K over 1. So if we have the cos of 25 degrees, we know that the cos of any angle is a ratio of which two sides? Matrix, cos 25, which two sides are we talking about? We were talking about this last week. The cos of any angle is what over what? Yes, Faheen, go for it.
Adjacent over hypotenuse.
Adjacent over hypotenuse, or in terms of x, y, and r, how would we write it?
X over R.
That's quite right. So we've got to write that as x over r. Perfect. So the way that we are interpreting this, okay, is that is our x and that is our r. Okay, that looks like a V, but it's my weird r. Okay, so that means that at the end here, we have the x coordinate is k. We don't know what the y coordinate is, and we know that the length of the terminal arm or the radius is equal to 1. All right, so like with the Pythagoras questions, we now need to use the theorem of Pythagoras to determine y in terms of k. All right, there we go. So x over r. Good. Well done, everybody. Yes, yes, yes. Okie dokie. So we would come along and we would say x squared plus y squared equals r squared. Now it's time to substitute in. So we have k squared plus y squared equals 1 squared. And that means that y squared is going to be equal to 1 minus k squared. And therefore, y is going to be equal to root 1 minus k squared. All right, so now just a couple of things before we continue, right? I want to emphasize again, right? When you are doing ratio in terms of a letter, it is related to the questions that we are doing with Pythagoras, okay? So in other words, we are still using the theorem of Pythagoras to calculate the missing letter. The only difference is now is that instead of it having a value like it did when we were working with Pythagoras, it's now going to be in terms of a letter. All right. The other thing that I want to emphasize again is that unlike the questions on Pythagoras, where x and y change sign depending which quadrant you are working in, here we are always working in quadrant number 1. And the reason for that again is because we are going to be working with acute angles only. Okay, so it's a different type of question, even though we are still using the theorem of Pythagoras. So now when I found y, I didn't worry about plus minus. Normally I would, okay, but I'm not going to worry about plus minus because I know in the first quadrant, both x and y are going to be positive. Okay, I hope that I have emphasized that enough and that that makes sense to everybody. All right. So now the other thing that I want to ask you about before we go and sub in is is it possible for me to separate the 1 and the k squared? Can I drop, or should I say this? Can I drop the square off the k? Because there's a square root sign. Can I do that? Spilile? You're welcome to unmute. Hi.
I think you can put them in brackets to the power of 2.
Okay. Will that mean the same thing?
If you want to drop the square root.
Yes. Can
Yeah,
I do that?
Yes, I think yes.
Okay. All right. It's just interesting to hear what different people are saying. There's lots of yeses and there's lots of no's going on in the chat. Okay. So first of all, you can't drop the square root. Okay. You've got to keep the square root there because we're solving for y, and the opposite operation of a square is obviously a square root. Okay. You cannot drop the square off the k either. And the reason for that is this, okay? If you have something like, let's say I have 100 minus 64. If I drop the square off the k, it's the same as, then I'm taking the square root of both things, right? So in other words, what I'm saying then is that that's the equivalent of this. Okay, if I drop the square off, all right, it's not correct, because if we take the square root of 100 minus 64, that would give us the square root of 36 would be 6. If we did it this way, what we're saying is 10 minus 8, the answer would be 2. So 2 and 6 are not the same. All right, so it's not okay for us to drop the square off the k, all right, or to separate the 1 from the k squared. Okay, it's got to stay just like that. The reason that it looks as though I've dropped the square off the 1 is because 1 squared is 1. Okay, 1 squared is 1, but k squared is not k. All right, so I can't drop the square off the k, even though it looks as though I've dropped the square off the 1. Okay, everybody, it's got to stay just like that, and it's positive because we are working in the first quadrant. So what that means is that we now have x, y, and r in terms of k. So x is k. Let's just make a little summary of that. So x is k. Y is root 1 minus k squared. And r is equal to 1 in terms of this diagram in this particular question. Okay, so now that we have that, we're ready to go ahead and go and answer the questions. All right, now bear in mind, we may need to use compound angles, double angles, as well as our normal trig reduction formulae. All right, so let's have a look at the first one. They give us the cos of 155. So let me write that down. The cos of this out the way, the cos of 155 degrees. Okay, so now I've got to express my angle in terms of 25 degrees. What am I going to do here, Matrix? How am I going to express this? There we go, quite right. So it's going to be 180 minus 25. I'm going to reduce. Okay, and what's my answer to my reduction going to be? If I use 180 minus, what am I going to end up with here? Careful signs, Palesa. Remember 180 minus is quadrant 2, where cos is. There we go, negative cos 25. Okay, so that is the biggest problem for us in trig, is that we forget about signs. Okay, it must be negative. Must be negative. All right, matrix. Good, lovely. And now we know what the cos of 25 is. We know that it's k. So negative cos 25 is going to be negative k. All right, so something like this would be out of 2 marks, 1 mark for writing what you get after you reduce, which you have to do, and another mark for your answer. Okay, lovely. Well done, everybody. That was great. Let's have a look at number 2, the cos of 50. Okay, so what do we notice about the number 50 and the number 25? What do we notice? They are, well, 50 is? There we go. It has to be a double angle. Good. Good. 50 is double 25. Beautiful, Pelesa. I couldn't have said it better. Quite right. So 50 is double of 25. All right. So now we have to express this in terms of K. Any ideas? Yes, certainly is. All right. I can write that. I'm not going to get any marks for writing that, but I'll do it anyway. All right. Now remember, we've got 3 options here, matrix. Okay, for our cos double angle, it's just there peeping out at the top of our screen. We've got 3 options, either cos squared A minus sine squared A, or 2 cos squared A minus 1, or 1 minus 2 sine squared A. We've got 3 options. All right, which option should I choose? Yes. Which option should I choose? The second one, Teddy says. So does Nadia. Okay, all right. So 2 cos squared A minus 1. Let's do that. So we're going to write this as 2 cos squared 25 minus 1. And we know what the cos of 25 is. We know that it's equal to k. So this is 2k squared minus 1. Okay, yes, absolutely. All right, absolutely, guys, because we've got the cos of 25 anyway. All right, good stuff. How's everybody feeling? Is this making sense? Are we all good? Are we happy? Thumbs up. Are we okay? Cool. Good. Oh, good. I'm so glad to hear that. All right, and again, we would get 1 mark for expanding our double angle and another mark for our answer. I'm just going to check what you guys are saying in the chat. Okay, all right. Thanks for all the thumbs ups. Good, well done, everybody. Okay, now let's have a look at number 3. They want us to express the sine of 25. Remember, our diagram is in terms of 25. So sine 25 is actually very easy. Anybody got an idea what I should write for the sine of 25? Oh, Nhlantla says, and can you see this in Y option 2? You know what? I just prefer that one personally, but really any of them would work. If you chose one of the other 2 options, you'd end up with exactly the same answer. So before I go on and I do question number 3, let's just have I'll just show you very quickly. So if you did cos 50, cos 50, and you said it was equal to cos squared 25 minus sine squared 25, you get exactly the same thing. So cos squared 25, cos 25 is k, so that would be k squared. Oopsie, why am I writing equals and I'm meant to be writing minus? Sorry, minus, and then sine squared 25. The sine of 25 is root 1 minus k squared. So if we sub that in, we've got 1 minus k squared, and then we would need to square that as well. So that would give us k squared minus 1. Negative times a negative is a positive, k squared, because remember, the square is going to eliminate the square root, and k squared plus k squared is 2k squared minus 1. Do you see why it's the same answer? So that's why it doesn't matter which one you use. Okay, and similarly, if you did it using this one, 1 minus 2 sine squared 25, you'd also get the same answer. So it'd be 1 minus 2. Then we're going to sub in the sine of 25 is 1 minus root 1 minus k squared, except we need to square this. Okay, so that would leave us with 1 minus 2 into 1 minus k squared, because the square and the square roots are going to cancel each other out, right? And now you would end up with 1 minus 2 plus 2k squared. And again, if you rearrange that, it would be 2k squared minus 1 would be your final answer. Okay, matrix, so it doesn't matter which one of them you use. Okay, it would not matter. Okay, so Teddy, you were saying something about cos 75. What were you referring to? Oh, you mean what sine 25 is equal to? Are we going back to that? Okay, so remember our diagram is in terms of 25 degrees. So we've actually done all the work. This question is actually a bit silly. It should have come first. Because out of all of them, it's actually the easiest. We've actually already worked out the answer. The sine of 25 is y over r. Remember, y in terms of k is root 1 minus k squared over r is equal to 1. You don't have to write over 1 though. I'm just putting it in there for you guys, but you wouldn't actually have to do that. Okay, so that's what you would end up with for the sine of 25. Everybody good? It's actually the easiest question. I don't know why it came third. It should have probably come first. All right, and then let's do question 4 next. Okay, so here, the sine of 50. Okay, so the sine of 50. So 50 is also double 25. So what should we write here, matrix? The sine of 50 is equal to? Can anybody tell me? If I move up, would that help? That's it, 2 times 25. So using our double angle expansion, there we go. Well done, Nadia. Yes, it would be 2 sine 25 cos 25. Yes, Nolwazi, that's exactly it. Okay, so that's how you would write it, as 2 sine 25 cos 25. There we go. You've expanded it. Remember, you'd get a mark for that. And now you're going to go and sub in. Okay, so it's 2 times the sine of 25, remember, is root 1 minus k squared multiplied by the cos of 25 would be k. So just writing that in how we would normally write it, we would put the 2 and the k together at the front, and then we'd put the root 1 minus k squared behind it, and it would just be left like that. Okay, there we go. All right, so again, there would be a mark for expanding and a mark for the answer. Okay, all right. Are you guys ready to try one of these on your own now? I think we are. Amu, I didn't hear your mic on. Okay. But it's very kind of you to apologize. All right, what I'm going to do, I'll just grab this so that you guys have got it. And I'm going to put it over there. And, oh, come on, you silly thing. Sorry, Matrix, let's just get that sorted. There we go. Okay, so you are doing this question here. If the sine of 18 is equal to t, determine the following in terms of t. Okay, so it's quite a lot of work there, Matrix. It's questions 1 through to 4, but I want you to practice these because it's really, really good practice for you. And then we'll go through the answers afterwards. Okay, Nulwazi, no, you can't simplify that. The 2k times the root. So only if you've got a square root times another square root, then you can multiply. Like let's say if you had root 3 times root 1 minus k squared, then you could multiply the 3 and the 1 minus k squared together and keep the root sign, but not that. There's no way you could simplify that any further. Okay. All right, no problem. So give that a try, Matrix. And when you think you've done up to and including question 4, then you can say thumbs up or done or whatever in the chat. Okay, and then we'll go through the answers. No problem, Lesejo, sorry.
Hi, Teacher Lee. Sorry I'm late.
Hey, it's all right, Yolanda, no worries. I was just writing to tell you I've got load shedding again at 6 o'clock. So
Okay, no problem. I
all
should
right.
be able to cover you. I don't have enough coverage either in terms of network connection, but
Okay.
I think it should be able to be fine. I'll pull it
Okay.
through.
All right.
Yeah.
Thank you so much. Sorry about that.
No problem.
Okay. All right, Kaylee, you want to see where I wrote the sine 50 again? Okay, there you go. So it's 2 sine 25 cos 25, Kaylee. And then I'm just moving it back down again.
Are we doing the exercises from 1 until 4 or just 1?
No, they're
1
going
until
all the way from 1 to 4. Yep. I'm making them do
okay.
all of it. Yeah, no, they have to do all of it. and then we'll mark.
Ooh, Lisa is done.
Okay, Lisa, well done. Good going. We'll
Let's
see.
go.
Okay. Don't rush, everybody. I know it's great that Lisa's done, and that's brilliant. Do it properly, okay? It's you don't have to feel pressurized. It's better to, some people just work faster than others, and that's cool. But just make sure that you do it properly rather than quickly. Okay, Linda Kuhle is also done. Okay, on Waba, you done, that's fine. What I can do is put an extension question. Sorry, it's just so difficult to fit everything on the screen compared to if you were in class. But anyway, never mind, we make do. Okay, on Waba's done, Sibon Gaintley is done. Sandisiwe is done, Zintle is done. Okay, cool. Nobasutu's done, Faheen's done, Wachepo's done. Okay, cool, guys, well done. We'll just wait another couple of minutes or so. You know what I think is so cool, Yolanda, is that it's holiday time and we've still got 76, okay, 74 minus you and I.
Yeah,
Matrix here, hey? How incredible is that? That is real
that's
dedication.
really amazing. It's
Yeah,
really amazing because
absolutely.
other people just want to be on holidays and forgetting that they're in
Absolutely.
the trick.
Absolutely. Absolutely. But here these guys are still doing their lessons. And in fact, when I logged in today, I think I joined a bit earlier and I just decided I was going to wait. There were like 2 people joined at like 25-2. Like that's how keen they were. Isn't that amazing?
Wow,
I
25
know.
Whoa.
Absolutely.
So, let me just
Oh,
help Ayanda on the task.
yes, just help Ayanda. Kamagelo, which questions? Maybe let's go back and go and have a look. Okay, you know what? Hi, Kamagelo.
The sine 2a one, the Pythagoras one that we did last week.
Okay, All right, you're right. Absolutely. We must go back and go and do that. All right. So what
Thank
we'll
you.
do is we'll go, no problem. Thank you for reminding me. We'll go through these answers and then we'll spend the rest of this lesson just talking about that because that's a very important concept and it is something that is going, yes, that's right, Siam Tanda, I remember now, was how we did sine A. Absolutely. Okay, so let's go back to that. All right, so the answers to these, let's just go through them quickly. All right, so in number 1, the cos of 18, hopefully you would have drawn the diagram. And our diagram would have looked something like that. And there was our 18 degrees over there. And we would have had x here and t here, and that would have been 1. And when you solve for x, what did you get x equal to? Matrix, does anybody want to tell me what the x value is in terms of t, please? What was x in terms of t? Faheen, go for it.
It will be root 2t squared minus 1.
So it should have been 1 minus t
Minus
squared.
t squared. Excuse me.
1 month.
Excuse me.
No, it's okay. No, please, it's absolutely fine. We all make little mistakes. Perfect. Okay, so you should have had root 1 minus t squared. Lovely, good job. And that would have been the cos of 18. Okay, so cos 18 in this case would be root 1 minus t squared over 1, but really, if you don't write over 1, it's not the end of the world. Yes, good job, everybody. That's perfect. All right, now, number 2, the sine of 78. Okay, so can anybody tell me what did you do with that? What did you do with the sine of 78? How did you do that one, Matrix? Okay, I agree. It involves special angles, Linda Kuchle. Anyone want to give me their answer? What did you do? How did you, what sort of angles did you use here? The sine of 78. Okay, so Faheen did 2 times 39. Okay, but the only problem with that, Faheen, is that our diagram was in terms of 18. Yes, Sharon. So unfortunately, that would be incorrect because when you subtract, it's like when you divide, the order matters. So t squared minus 1 is not the same as 1 minus t squared. Okay, so in this case here, it would have been 1 minus t squared, not t squared minus 1. This, you can have this. You can have this. It would normally be a plus, but that's if they had given you, it happens with tan, where you would have the length of the where you would be calculating the length of the hypotenuse. All right, but yeah, it's not the same thing. Okay, and it would be marked wrong. Okay, so a lot of you have written that this would be equal to 60 plus 18. Well done, Matrix. That's excellent. So you recognize that it was a compound angle. So you would have expanded this and said sine 60 cos 18. Sine keeps its sign. Cos 60 sine 18, like so. Let's just move this out the way. And then we've got space to write. And now we can go ahead and go and sub in our special angles. So the sine of 60 is root 3 over 2. The cos of 18 was equal to t plus the cos of 60, that is 1 over 2. And the sine of 18 was root 1 minus t squared, like so. And to be honest, Matrix, you actually don't have to simplify it any more than that because they're not like terms. So if you've left your answer just like this, it would be perfect. Okay, so the marks here would be for recognizing that it was a compound angle, expanding your compound angle, and then go and substitute incorrectly. Okay, so if you did do that, Very, very, very well done to you. Okay, now number 3. The sine of 36.
I don't remember.
Okay, did I put something in the wrong place here? Hang on. Sorry. Let me just go and have a look.
Mm,
Oh, the sine of 18. Yes, beg your pardon. Beg
mm.
your pardon. Yeah. Sorry, I put the wrong thing in the wrong place. So it would have been like this. So that would have been root 3. And then here, this would have been times root 1 minus t squared plus the cos of 60 would have been a half. And then that would have been t. Sorry, there we go, matrix. Okay. Is that better? Favor? Were you just going to say the same thing?
Yes, ma'am. Yes, ma'am.
Okay. All right. My apologies. Sorry, I thought it was the cos of 18 that was t, but you're right. It's the sine of 18. That's t. Okay. All right.
It
So now
shows everyone is wide awake. I like it.
absolutely. You know, at school, I always used to say to the boys, yeah, I made that mistake on purpose to see who was paying attention. So clearly
That's
the
a good
people
one.
it's a good way of covering your backside, isn't it?
Yeah.
Oh goodness. But anyway, it is actually good to make mistakes like that because it does show that people are paying attention, which is great. Well done, Faber, and whoever else was trying to tell me that I'd made an error there. Cool. All right. So sine 36, that would be, does anybody want to tell me what we would write here? Just so it's not my voice all the time. Yes, Naledi, go for it. What would you write here, Naledi?
Hi, ma'am.
Hi.
Hi. I wrote sine 2, open bracket, 18, and my answer was 2t.
Okay, so now, Naledi, once you do this, once you write sine 2 times 18, you must write 2 sine 18 cos 18, okay? Because if you don't, you're not going to get a mark for that. All right, so make sure that you put this step in as well. Okay, and then what did you have after this?
My final answer was 2t since
2t.
yeah.
Okay, so I understand the 2 and I understand the t from the sine 18, but what about the cos 18? You'd have to sub in the root.
Oh,
1 minus, you just
t
left that off. That's it.
Yes.
Perfect. Well done. Well
Thank
done. Very nice. Good job. Okay. Please mute. Please mute. Thank you. Okay. So yeah, guys, don't forget you have to write what you get when you expand. So like over here where you expand your compound angle formula, you're going to get a mark for it. Over here where you expand your double angle formula, you're going to get a mark for it. Okay, so make sure that you write those lines because you're going to get marks for them. Okay. All right. Where were we? Oh, the last one. Okay, number 4. And here they gave us the, was it the tan of 198? The tan of 198. All right, so anybody want to tell me what they did with this question? Go for it, Onwaba. All yours.
Ma'am, I used the as 180 plus 18,
Mm-hmm.
and
Lovely.
then it was equal to tan 180, whereas we already have the angle is 18. So my answer was square root t squared minus 1 over t.
Okay, let's just go and have a look at your final answer. Okay, now did you perhaps make the same mistake at the beginning where you wrote x as t squared minus 1? Did you do that instead of 1 minus t squared?
X is
Just go back.
Where, ma'am?
Okay, so at the very beginning, when you worked out what x was in terms of t, did you get root 1 minus t squared or did you get root t squared minus 1?
root t squared minus 1.
Okay, all right. So t squared minus 1 and 1 minus t squared are not the same thing. Okay, on Waba. So it's 1 minus t squared. And let me just show you, I didn't show you guys from Pythagoras why, but let me just show you that quickly because we were talking about that earlier. All right. So what you would have done is you would have said x squared plus y squared. So that would have been t squared is equal to 1 squared. And then you would have left x squared this side and you would have taken 1. And then you would have taken t squared over to the other side. You see that? So that's why it has to be 1 minus t squared. And then when you solve for x, it's going to be the square root of 1 minus t squared. Okay, so it was lovely what you wrote here. It's just the inside there that would have been incorrect. Okay, so here it was supposed to be 1 minus t squared. Okay, y over x.
Thank you.
Okay, good job. Well done. Very, very nice. Okay, so Nhlanhla the other way around. Okay, so root 1 minus t squared over t, because remember, the tan of any angle is y over x. So if you remember last week, I showed you this thing, SYR, CXR, TYX. Okay, so y has got to go at the top and x has got to go at the bottom. Oh, hang on, am I talking? Yes, hang on. Ah, there we go. Yes. Quite right. Okay, so it would have been like that. It would have been t at the top over root 1 minus t squared because y was equal to, that's it, y was equal to t and x was equal to 1 minus t squared. There we go. All right, perfect. That is now correct. Okay, yes, Nolwazi, you are correct as well. Okay, so yeah, we've just got to be careful of that. Remember, tan is y over x. So t over root 1 minus t squared. Okay, did anybody manage to get all 4 correct? Oh, that's okay. Good. Well done. Linda Kuhle, Sibongenhle, Nhlanhla, Kaylee, Nobasutu. Nice.
Wow, guys. Wow.
Yes, 3 out of 4,
people.
still brilliant. Well done, Lisa. Very
Well
nice. Good job.
done.
It will, Faheen. You just got to keep trying. Only got 3. No, don't say only. That's awesome. Okay, 3 is
The three is
great.
also the best. Yeah.
Absolutely. 3 out of 4 is perfect. Well done. Yeah, these workup
The
questions.
tricky thing
All
is
right.
that they only make like a little bit of mistake, and then of course everything goes wrong.
Yeah, that's
But if
unfortunately
you
the
realize that
problem.
the little mistakes, yeah, the little mistake can make you just do everything wrong.
Yeah, absolutely. Okay, so let's go back and go and have a look at that question. This is the one that we were talking about last time. All right, so in the last 15 minutes, because it's going to take a little bit of an explanation, let's just go back and go and talk about this. All right, because I remember I said to you that I needed to show you this because it's something that does come up quite a lot. Okay. All right, so if you recall from last time, we worked in terms of an angle that was 2a. It was root 5 over 3. We had then said that 2a was an angle between 90 and 270 because our ratio is positive. We decided we were working in the second quadrant. So that meant that we were able to calculate the value of cos 2a, which was minus 2 over 3, and of tan 2a, which was equal to 5 over minus root 2. Now, in these sorts of questions where they have given you your angle in terms of 2a, and they ask you to work back to sine A, all right? A common mistake here is people think that if they halve the ratio, they'll halve the angle, all right? And that simply is not true, okay? So I just want to talk about that a little bit. Let's just think about something that you know, matrix. If I ask you for the sine of 90 degrees, what is the sine of 90 equal to? Can anybody tell me what the sine of 90 is equal to? It's equal to 1. Absolutely. Now, if I halve the angle, so now I'm going to talk about the sine of 45 degrees. What's the sine of 45 equal to? The sine of 45 is root 2 over 2. Okay, I halved the angle. Did I halve the ratio? I halved the angle. That's it, Sharon. I halved the angle. Did I halve the ratio? No, I didn't. Okay, no, I didn't. Let's take another example of something that we know. Okay, let's talk about the sine of 60. The sine of 60 is root 3 over 2. What's the sine of 30 equal to? It's equal to 1 over 2. So another example, I halved the angle. Did I halve the ratio? No. All right, and that is because when you are working with sine theta and cos theta, you are working along a curve. You're not working along a straight line. Remember, sine graphs and cos graphs are curved. Okay, and that is the reason for this. That's why if you halve the angle, you are not halving the ratio. Okay, so for a question like this, halving the ratio does not work. Okay, and I've shown you why now. So this is what we need to do. Okay, and this is the part that's a little bit difficult for us to understand in the beginning. Cos 2a is very, very useful because it can be used to calculate cos a and sine a, because cos 2a is equal to 1 minus 2 sine squared a. So you can solve for sine a using this formula. Okay, and then what you would do is you would go and sub in. So in other words, we know what cos 2a is equal to from our diagram. In this case, it's equal to minus 2 over 3 equals 1 minus 2 sine squared a. So we are going to solve for sine a. What I'm going to do is I'm going to take my minus 2 sine squared a over to the other side and change its sign and give me 2 sine squared a. And then I'm going to take this over to the side. So it's going to be 1 plus 2 over 3. So now I don't have to work with negatives anymore. Okay, and then I'm going to say 2 sine squared a is equal to 1 plus 2 over 3 is going to give me 5 over 3. Now I need to divide both sides by 2. That's going to give me 5 over 6. So that means that sine squared a is going to be equal to 5 over 6. And now I need to take the square root. Let me just move that down and that down. And now I'm going to take the square root. All right, so sine a is going to be equal to the square root of 5 over 6. I should also consider plus minus here. All right, but I'm just going to go back and have a look. All right, 2a meant that I was in the second quadrant. So half of a means that I would then be in the first quadrant where sine a would be positive. So I'm only going to consider the positive answer over there. Okay, now that's the bit that I wanted to show you or have a bit more of a discussion about. All right, so if you work in terms of 2a and then they ask you for a question in terms of a, you can use cos 2a to get sine a or to get cos a. So cos 2a can be used to solve for cos a or sine a. All right, so here we solve for sine a. If we were going to solve for cos a, what we would do is this. We would write cos 2a equals 2 cos squared a minus 1, and then we would solve for cos a accordingly. Yeah, we just wouldn't include it here, no wazi. Okay, you just wouldn't include it here. Okay. Have you guys seen this at school? Have your teacher showed you this? For those of you that have done trig at school, have you seen this before? Okay, so some of you have, some of you haven't. Okay. All right. Okay. Are there any questions? Are you sure? You understand. You have not seen it, but you understand what I've done here. Okay. All right. So I'm going to give you an opportunity to practice this idea. All right. In terms of a homework question. Yes, that's fine. No problem, Pelesa. I've got a question for you guys here. Okay. So quickly, Dimple, what do you not understand? Okay, we were working in terms of 2a, and the question asked us for sine A. All right, we spoke about why dividing our ratio by 2 doesn't work, which is a common mistake. And that's because when we're working with a sine curve or working with a sine graph, we're working along a curve. Okay, so half of the sine of 60 is not the same as the sine of 30. Halving the angle is not the same as halving the ratio. So we have to use our cosine double angle expansion to either solve for cos A or sine A. So depending on what they ask us for, if they ask us for sine A, then we use cos 2a is 1 minus 2 sine squared A. If they ask us for cos A, then we use cos 2a equals 2 cos squared A minus 1. Okay. All right, so what I'm going to do is just scroll down here. This is the question that I want you guys to try for homework.